Hi, how's it going? Going to do a quick review of the Drok transistor tester bought from Amazon. And these are, there's a million of these different models. They all kind of look the same. They all kind of do the same thing. And this Amazon seller, Drok, looks like they've branded them under their own brand. It's their seller name. And so let's do it. Just want to do a quick review, show you what it can do, what's possible with it, and a little bit of also what it can't do. So, okay, let's get going. So let's go here. So this is what the actual unit looks like, and comes like this in a case. Not all these ones that you see on Amazon actually come in a case, and it's got basically some pins here to plug in the different components that you're testing, and a screen, and then it actually comes with this nice little ZIF socket that you can plug in here, which makes it easy to put your components in. But notice that down here, there it's labeled 1, 2, 3, 3, 1, 2, 3. Really what you're doing is you're going to put, if it's a 2-wire component, you're going to put it across 1 and 2, or 2 and 3. But you can put one end of it in this one spot here. You can put one in here, in this one, and then put the other wire over here in this 2 or in this 2. So this basically makes it really easy, depending on the layout of your part, to make it actually fit in here. We don't have to bend the wires around too much. So to turn it on, you basically just press the power button. It takes a minute or so. Well, not a minute. It takes about 10 seconds or so to boot up. And so we'll just start off with something simple here and put in a 100K resistor. So right now there's nothing in here. So of course it says unknown. And so I'm going to take this 100K resistor and put it across. So that's going right now across pins 1 and 3. I'll close that and I'll press test. And it will run through here. There we go. It shows that there's a 97.5K ohm, so close enough to 100K. The tolerance on this resistor here, these little quarter watts, aren't that great anyway. So it's connected between 1 and 3, so that worked. If I put in something larger, so this is a 1.8 megohm. So this time I'll put it across pins 1 and 2, stretched all the way across, just to kind of show how that works. Press this again. This will be 1.8 megohms. There you go, 1,836K, and it's across 1 and 2. So that works. And everything works. It works up to about 10 megs. So here's a 22 megohm resistor, and we'll see that it has no idea what this thing is. So I'll start this. So it works. It looks like it works up to 10 megohms with all the different values that I tried, which is pretty good. And I went all the way down to 1 ohm. And once you get down to these small values, it's hard to measure because of the long leads. There's actually another technique you have to do for that. But it successfully reads all the low values, all the way up to 10 megohms. Seems to be fairly accurate. So anything above 10 megohms, it's not going to do. So okay, next thing we can do is capacitors. So here's this is a 0.047 kind of mylar cap. I'm going to put in here across 1 and 2, and hopefully we can get it out of the way of I'll have to get it actually in the slot here. Okay, I'll bend it out of the way so we can see. There we go, 46.68 nanofarads, which is the same thing as 0.04668 microfarads, or 0.047 microfarads. So that's reading great. And ceramic type or mylar capacitor, not an electrolytic. So you'll notice that the symbol it's actually showing you here doesn't have any polarity. There's no plus or minus to this. So it's actually able to determine the type of capacitor that's in here. So let's put another one in. Here's a 0.1 microfarad. This is kind of more of your typical ceramic cap, pretty low tolerance on these. So we'll see what we get with this 0.1. Yep, 86.1 nanofarads, which is the same thing as saying 0.086 microfarads. So very close to 0.1. So within tolerance there, so that's working. And I'll plug in an electrolytic. Here's a 100 microfarad electrolytic capacitor. So same thing, we'll stick it in here across, say, 1 and 2. And notice I don't have to care about the polarity that I'm putting in here, even though this is an electrolytic and does have polarity. It doesn't matter. It figures it out. Well, actually, it didn't do it in this case. Didn't tell me which side. So this is a 86.2 microfarad. It's labeled 100 microfarad. It's also telling you the series resistance. I tested this against a real LCR meter, and it's kind of close, but I think these little cheap meters are really better for identifying parts, getting a good idea of what they are, and getting pretty close to the values. But they're only this is going to be like plus or minus 10% or something. So let's take this out, and here's a little much smaller one at 2.2. So we'll put that in here between 1 and 2. Oh, notice it counts down and shuts off. So once that happens, you got to turn the thing back on again. They had a nice transformer logo there at the beginning. Wondering whether they actually paid for the licensing for that. Doubt it. So there you go, 2,000 nanofarads. 2082, which is still the same thing as saying 2.082 or 2.2 microfarads. So it works with those. And so we can also put in different types of transistors. So here's a MOSFET I'm going to put in. This is an IRF 520. And again, it doesn't matter. It's a 3-wire, so you need to at least be putting it across 1, 2, and 3. And so I'm just going to put it in here. It doesn't matter what direction. Start the test. And the cool thing is this thing actually identifies what type of transistor you've put in, as well as gives you a diagram and what the pins are. So this is a MOSFET, N-channel MOSFET, and it's also telling you, here's the pins 1, 2, and 3. And if you look over here, you can see it's saying 1, 2, 3, which is gate, drain, source. So it's kind of nice. You don't actually have to kind of go look this up in the book if you don't know what the pinout is. So let's take that out. Let's do another one. Here's kind of a standard, I'm trying to read it here. I think this is a 3904, 2N3904, which is it's kind of like a cheap version of the 2N2222, your traditional kind of NPN bipolar transistor. And of course, there again, you have the right symbol, NPN, 1, 2, 3. So we have the emitter, the base, the collector. Properly showing here. Notice it's also showing the HFE, the gain, and the forward voltage. So it's kind of giving you the specs. And it's probably about right, actually, for the gain for this thing. And let's keep going. This next one is actually the 2N3906, which is the opposite of the 3904. It's another cheap version of a PNP version of kind of the 2222 or 2223. And again, it's giving us the nice diagram. The forward gain is similar, which is what we'd expect. So that works. And this one we'll put in is a MPF 102. It's actually an FET, a field effect transistor. It's actually a JFET. Let's see if this thing actually reads properly. There you go, and you do have the right in-channel JFET. And again, it's giving us what the legs are, 1, 2, and 3, the drain, the source, the gate. Okay, and some other statistics you can see there. And here's another, this one's actually a MPS A64. This is a Darlington transistor, which, let's see what it does here. So that is actually not right. So this is not a bipolar. These Darlingtons are actually inside. They're actually 2 transistors kind of connected to each other, so they amplify the gain. They're very high gain. So for all intents and purposes, it does look like this. It does look like a PNP bipolar transistor, and this is the right pinout. You just don't know that it's a Darlington, but you can kind of tell because if you look at this gain here, 68,000. So you know that this is not your standard bipolar. Before, remember, the numbers were like 200. So this thing is going to amplify the gain a lot if you use this, and that's because it's a Darlington. So, okay, let's keep moving on. This video is probably already getting too long. Here's a diode. This is a 1N914, kind of traditional silicon diode. Been around for eternity. And these have an anode and a cathode on here that you can kind of see. And this is properly showing, again, that it is a diode. It's the right symbol. And it's telling you which end is the anode, which end is the cathode. That's great. And it's telling you also the forward current. Okay, I'll take this out. and let's put in a Zener diode. And until it start up. So this did not properly read. This is still showing it as kind of a standard diode. I guess that's right, but you know, this is actually a 5-volt Zener diode, and so the symbol I would expect to see would be either the actual, looks like kind of like a Z right here for Zener, or the other way you sometimes can see a Zener symbol is a diode going this way, and then another diode going this direction, and that's another way they could have diagrammed it. But so this didn't quite properly recognize what a Zener looks like. That's okay. So we take that out. You can also do coils. So this is a 100 microhenry coil. So I'll put this in here and close it up. Get our probably illegal transformer logo again. And let's see what we get. Yep, 0.08 millihenries, which is the same thing. That's 80 microhenries, close enough to the 100 microhenry. So again, that's helpful if you, especially if you have a coil and you have no idea what it is. It should get you in the general range. So if you had something like this, this is like an old, choke coil, probably out of some old radio from a million years ago. But you could actually put it in here and measure it. So if I put it in across, again, 1 and 2, and read this thing. You can see here that, again, it did recognize it as an inductor, as a coil at 0.01 millihenries or 10 microhenries, depending on how you want to think about it. So it works. It works. I think it works pretty good. It's a useful thing to have on the bench to be able to measure components real quick and maybe do some quick tests and see whether values are at least within range or whether something's working. It was interesting. I did actually use this, and I have a capacitance substitution box, and so I just really quickly connected it up to it and found that one of the capacitors in my substitution box doesn't actually work. So that was really useful to be able to quickly just run through all of those and have this thing measure it and tell me if everything is kind of within spec. So hopefully that was helpful, and if you have any more questions, feel free to message me. Okay, thanks.